Welcome back to my channel. In today's video, we are going to talk about how to solve for arc length and sector area of a circle. Now, before we get started, let's first understand what arc lengths and sector area are and what the formulas are. So, arc length, basically you have a circle, and then we have two lines like this, and then the arc of the circle is, just like an arc, which is between the two lines, the distance between the two lines, and that is what you call the arc length. And there is a specific formula to solving an arc length of a circle. So the formula goes like this: S equals to theta times R. And S basically means the arc length, and theta is what you call the radians. So let's say in between the two lines I have an angle, and I have something like a value. Let's say it's 30 degrees, something like that, and that would be the angle, but then the theta here, it has to be in radian form. So this one, the angles, there are two types of angles, right? Remember, there's degrees and there's radians. And so when you get a degrees, you want to convert that to radians. And if you aren't sure of how to convert between radians and degrees, I do have a video in my channel, so please look for that. And continue on in our formula, we have R, which is the radius, so the length of these two lines, which is the radius. So for the sector area now, we have our circle, and in our circle again we have our two lines, and this time instead of finding the arc, we want to find the shaded region. So we want to find for this shaded region that looks kind of like a triangle, and that is what you call a sector area of the circle. And again, we have our formula for that, which is A area equals to 1/2 times theta times R squared. And so again, theta is our angle here in radians, and R is the radius. And so that's our formula. Now, to apply that, let's take a look at this question here. The diagram shows two circles that share the same center, and we have, you can see we have one circle inside and one circle on the outside, and it says the radius of the smaller circle is 8 cm, as you can see, and the larger circle is 10 cm. And then points A, B, C, so A, B, C. A, B, and C are on the circumference. That means that is the arc. And we have AOB is pi/3, so AOB, this is pi/3 radians. So this shows that we do not have to convert to degrees since it's already in radians. And now it says, question A, find the length of arc ACB, the arc. So you want to solve for this arc here. And remember, our formula is S equals to theta times R. And we know that theta is the angle in radians, so pi/3 times R. Now, which radius do we use? Now, this is a tricky question, but we know that ACB are on the circumference of the larger circle, as it says here. So we're going to use the radius on the larger circle, which is 10 cm. So times 10. And you can use a calculator if you want, or you can just leave your answer as just 10 pi/3 without using a calculator. Now, for question B then, find the area of the shaded region. So we have a shaded region here. We want to solve for that. So as you can see, it is not like what I said earlier. Instead, it has a specific region and not the whole sector area. So that means we have to do a few more steps. And so to do that, that means we want to solve for the sector area of the inner circle and the sector area of the outer circle. So let's do the sector area of the outer circle first. So let me just call it a big, that means it's the outer circle. So right now we're only focusing on the outer circle and to solve the area sector of this part here. So that would be, we look back at our formula, 1 over 2 theta, which is again pi over 3, times r squared, which is radius squared. So again, we're focusing on the bigger one, so it's 10 squared. And that we get, you simplify everything, we get pi over 6 times 10 squared, which is 100 pi over 6. And then for, now that we solved this one, this means we solved based on this diagram here. We solved everything here. We solved the whole sector area. Now we want to focus on the smaller circle and just focus on this part right here. So a small equals to, we use the formula again, 1 over 2 times, again the theta here, the angle is the same in radians, so pi over 3 again, times, this time we're using the smaller circle, so it's 8 for the radius, so 8 squared. And that we get pi over 6 times 8 squared, which is 64. 64 pi over 6. And now that we solved for this, and let me just create a smaller diagram here. This is the smaller circle. So we solved for the small one and the big one. Now we want to solve for this, only this section here. So a logical way to do it would be just to do this minus this in order to get the area on just the outer part. So we do a big minus a small, which is just 100 pi over 6 minus 64 pi over 6. And since they share the same denominator, we can just write what's 100 minus 64 is, which is 36. And if we simplify that, we just get 6 pi cm squared. Remember, we have to write the units down because we're solving for the sector area. And so there you have it. This is how you can solve arc length as well as sector area. Hope you guys enjoyed the video. Thank you.